This is question number 9. Diagram show a toy car doing a loop-the-loop. The car just remained in contact with the track at the top of the circle. The loop has a radius of 0.4 meter. If the car starts from rest at point A, so this is point A, is start from rest here, means that the initial velocity is 0. What is the height of A above the ground? So the question asks you, from the ground, what's this height? Okay, and if that's the case, one thing for sure is that you should use this ground level here as your reference level. Okay, so reference level RL equals to 0. This is where I define the potential energy to be 0. Okay, and you have to ignore any effect due to friction. Okay, so hint is given. So you have to find what is the height of A if the car at the top of the loop here just remain in contact. Okay, so one thing that we can start off with is looking at the free body diagram of the car at the top of the loop. There will be two forces. One is due to gravity, another one due to the normal reaction. Okay, and this is the center. And we have to form the equation. The FC at the top of the loop is W plus N. Because the net force must be pointing down, and Wn both pointing down, means that W and N add up to become the centripetal force. And one thing that we can simplify right now is that since the car is just in contact means that the N is equal to 0. Or whenever it says about not feeling any force from the seat, it is referring the same thing. So in other words, this FC is equals to W. Okay, and FC is mv squared over r. W is mg. So what we have here is that we have v squared equals to r multiplied by g. This is one equation that we can sure at the top of the loop. But you have to answer the real question here, what's the height here? So in order to answer such a question, you have to use the conservation of energy. Okay, and maybe I can write down the total energy at point A. Total energy at point A would be given by mgh alone because the speed is 0. Okay, and it will be equal to the total energy at point B. Let's say point B as the top of the loop. At point B, there is a potential energy, and also there is a certain speed, which means there is kinetic energy. At point B, what is the potential energy? It is still mg, but the height here would be no longer h. It will be diameter of this loop would be 0.4 times 2. It will be 0.8, and it has a speed of half mv squared. Okay, so this is one equation that we can use to solve for h. But first thing we can do, maybe we can ignore the m. So if we ignore the m, this is what we can simplify it slightly more. Ignore the m, they have v squared, and v squared here we can do something because we have equation number 1. So maybe we can try something from there. Okay, so half of what is v squared? V squared is rg. Yeah, it's rg. And r is 0.4. So maybe one thing I can do, simplify the g. So h would be 0.8 plus half of r. Yeah, and it will be quite simple. R is 0.4. So half of 0.4, 0.2, add up 0.8, you get 1.00 meter. So this shall be the answer that we want. It must be this height that we are referring because it's from the ground. So this is the quick solution. You must be able to master the centripetal force equation and how to use the conservation of energy.